Hello students, welcome to NFN Academy of Chemistry. Today we are going to discuss a very important topic, batteries and fuel cells, present in the electrochemistry unit of class 12 NCERT. We are going to discuss the following topics. First, we will understand what is a galvanic cell, how to get batteries from cells, what are the differences between primary and secondary batteries, illustration of some commonly used batteries. Then we will go to the fuel cells topic. We will understand the differences between batteries and fuel cells with one example, hydrogen oxygen fuel cell. Some animations are included to facilitate the understanding. First, what is a galvanic cell? A cell means a device. For doing electrochemical studies, we need a device. The device is called a cell. There are two types of electrochemical cell. One is galvanic cell. Another one is electrolytic cell. A galvanic cell generates electricity from chemical reactions. We get electricity from galvanic cell, whereas in an electrolytic cell, we have to supply electricity to do the chemical reactions. The next question that should come to your mind is, can we generate electricity from any chemical reaction? The answer is no. Then which chemical reactions can generate electricity? Oxidation reduction reactions involving electrons. Only these type of reactions can generate electricity. Oxidation reduction is defined in different ways. For example, addition of oxygen, removal of hydrogen, or removal of electrons. All these are oxidation reactions. Similarly, removal of oxygen, addition of hydrogen, or addition of electrons. These are all reduction reactions. To do electrochemistry, we need oxidation reduction reactions which involve electrons. Only these type of reactions will be able to give electricity. Now, what are the basic components? Okay, now we know what is a galvanic cell, which type of reactions can give electricity. The next thing we should understand is, how do we construct a galvanic cell? The first basic component are the electrodes. We need a positive and a negative terminal. So, we need two electrodes. Again, the question is, can we take any two electrodes? The answer is no. We want to generate electricity. So, we have to select two electrodes having different E0 values. What is E0? That you know, standard redox potential. It tells you the tendency of a metal to undergo reduction or oxidation. We have to select two electrodes having different E0 values. Next, we need a solution, electrolyte solution. Electrodes conduct electrons. Electrolyte solution conducts ions. That is how the circuit will be completed. Let us look at a simple example for a galvanic cell. Daniel cell is a very good example. First, what do you need? We need two electrodes. Here in Daniel cell, we have a zinc electrode and a copper electrode. What is the condition? The two electrodes should have different E0 values. Check the E0 value. Zinc has an E naught value of minus 0.76 volt. Copper has a E naught value of plus 0.34 volt. Okay. So our second condition is satisfied, different E naught values. Next, what to understand is we need solution, electrolyte solution. The zinc electrode is dipped in zinc sulfate solution, which contains Zn2 plus ions. Next, the copper electrode is dipped in copper sulfate solution. Once you connect these two electrodes to an external circuit, what happens? You see, the electrode having higher E naught value, here in this case copper. To decide which E naught value is higher, you have to consider along with the sign. So plus 0.34 is a bigger number than minus 0.76. Okay. So copper has a higher E naught value. The electrode having higher E naught value will act as the cathode. The electrode having lower E naught value will act as the anode. Okay. In cathode, reduction occurs. Cathode is the electrode at which reduction occurs. Anode is the electrode at which oxidation occurs. So this is how you decide which electrode will be the cathode and which one will be the anode. Okay. Now let us look at a simple animation to understand how this cranial cell actually works. Look at this animation. As I said, at the zinc anode, what is happening? Zn is getting dissolved. Zn is getting oxidized into Zn2 plus ions. The Zn2 plus ions will go into the solution. Okay. If you zoom into this, you can see that one by one Zn atoms are going into the solution as Zn2 plus ions. During oxidation, each zinc atom releases 2 electrons. Where the electrons will go? The electrons will go along the zinc electrode and they will travel through the external circuit. That is how you get electricity passing through the external load. Okay. Then here what happens? Electrons are reaching the cathode. From the anode, electrons are reaching the cathode. At the cathode what happens? Copper ions, Cu2 plus ions present in the solution will pick up the electrons and they will get reduced. See, each Cu2 plus ion will pick up 2 electrons and they will deposit as copper metal on the electrode surface. Okay. If you take a closer look, you can see here. Each copper ion picking up 2 electrons and it is getting deposited on the copper cathode. As a result, what happens? As the battery is operating, the zinc anode becomes thinner and thinner, whereas the copper cathode will keep on growing in size. After a certain amount of time, the zinc anode may completely dissolve and disappear. That is when we say that the battery has drained. To connect these two solutions, these are called half cells. This is the anode compartment where the anode half reaction is happening. This is the cathode compartment. Connecting these two half cells, we have a U-shaped tube, which is called the salt bridge. The purpose of the salt bridge is to complete the circuit. We see that the electrons are moving through the external circuit, and here what happens? Copper ions are getting reduced and deposited. Okay. So there is a depletion of positive charge here. So what happens within the salt bridge? We have saturated KCl solution in other medium. So we are seeing that the K plus ions are moving towards the cathode compartment. Similarly, in the left hand side, in the anode compartment, what is happening? Zinc is getting dissolved as Zn2 plus. So there is an accumulation of positive charge in the anode compartment. To neutralize that, the chloride ions, the negative chloride ions are moving towards the anode compartment. Okay. Along with them, sometimes the sulfate ions from the copper sulfate solution will also move towards the anode compartment. Similarly, some of one or two zinc ions can be moving from the anode compartment to the cathode compartment via the charge bridge. So I hope you understood this animation. Now let us go back to the PPT. How to calculate the cell voltage? Cell voltage E0 cell is calculated as E0 cathode minus E0 anode. Here what is the cathode? Copper is the cathode. Its E0 value is plus 0.34 minus zinc is the anode whose E0 value is minus 0.76 volt. So we get total plus 1.1 volt. While calculating the E0 cell values, you have to take the E0 value of the individual electrodes along with the sign. For example, here you should not write plus 0.34 minus 0.76. If you put, you will get the final value wrong. You have to take along with the negative sign and put inside the bracket. Next, we will go to batteries. How do we get a battery? A battery is formed by connecting several cells in series. Just now we saw one single Daniell cell. If you connect several such Daniell cells in series, you get a battery. Why we have to connect them in series? Because from a battery, we are expecting a higher voltage. So we are connecting the cells. What is meant by series connection? You have to connect plus to minus like that in an alternating way, plus to minus, minus to plus, like that you have to connect as shown in the diagram. So when you connect in series, what happens? The voltage of the cells add up to give a total value. For example, if you want a 12 volt lead acid storage battery, you have to connect 6 cells in series. Okay. In series connection, only voltage adds up, current remains the same. There are two types of batteries, primary and secondary battery. Very simple. Primary batteries cannot be recharged. As we saw in the case of the Daniell cell, once the battery is drained, you have to dispose it and get a new battery. That is a primary battery. Secondary batteries can be recharged. We are going to see some examples in the next few slides. Primary batteries, we have already seen Daniell cell. We are going to discuss Leclanche cell and mercury cell. Under secondary batteries, we are going to see two examples, lead acid battery and nickel cadmium battery. Leclanche cell is a primary battery that is single use. Here the anode is zinc. Here also, like in the case of Daniell cell, the anode is zinc. Cathode is MnO2 powder. Electrolyte is a moist paste of ammonium chloride and zinc chloride. In commercial batteries, we rarely use liquid electrolytes because we want to transport the batteries and use to avoid spillage and for portable applications, we don't use liquid electrolytes. Okay. For example, we are using batteries in cell phones, laptops, and if you shake the battery, we don't hear any liquid. So we use solid polymer films in those batteries. Here, in this case, in Leclanche cell, we are using a moist paste of ammonium chloride and zinc chloride. At the anode, oxidation occurs. Zinc will be oxidized to Zn2+, releasing 2 electrons. In the cathode, reduction happens. Here MnO2 is reduced into MnOOH. The oxidation state changes from Mn plus 4 to Mn plus 3. We get the overall cell reaction when we add up the anode and cathode reactions. Here you have to notice one thing. The zinc ions combine with ammonium ions to give a complex as the product. The cell voltage will be 1.5 volts. Next one is the mercury cell. In this case, the anode is zinc amalgam. As the name indicates, mercury will be here. So ZnHg, zinc amalgam anode. And the cathode is a paste of mercuric oxide and carbon. Here also the electrolyte is a moist paste of KOH and zinc oxide. At the anode, zinc is oxidized to ZnO, and at the cathode, HgO is reduced to Hg. This is the overall reaction, and the cell voltage is 1.35 volts. Lead acid battery. It is a secondary battery. You would have seen in household inverter battery systems. That is, that battery is lead acid battery. Here the anode is lead. Cathode is lead dioxide, PbO2. Electrolyte, here we use liquid electrolyte because we are not going to move the battery around. It will be stationary battery, so we can use liquid electrolyte. 38% sulfuric acid solution is used as the electrolyte there. At the anode, lead is oxidized to lead sulfate. Pb becomes Pb2 plus. At the cathode, PbO2 is reduced to PbSO4. That is, lead is reduced from +4 oxidation state to +2 oxidation state. This is the overall reaction where you get lead sulfate as a product. The cell voltage of a single cell is 2.05 volt. That is why when you need a 12-volt lead acid battery, you have to connect around 6 cells, lead acid cells in series to get a 12-volt battery. Next one is nickel cadmium battery. This is also a secondary battery. Here the anode is cadmium and cathode is nickel oxyhydroxide, NiOOH. Electrolyte is a paste of potassium hydroxide of concentration 20 to 35%. At the anode, cadmium is oxidized from 0 state to +2 state. At the cathode, nickel is reduced from 3 plus to 2 plus state. Nickel oxyhydroxide becomes nickel hydroxide. We get the overall reaction by adding up the individual half reactions. This cell gives a voltage of 1.42 volts. Next topic is fuel cells. What is a fuel cell? As the name indicates, we are going to feed some fuels and we are going to generate electricity directly. In a thermal power plant, what do? We burn the fossil fuels. There also from fuels we are getting electricity. First, the fossil fuels are burned, which is used to generate steam. Then the steam is used to run a turbine where it is converted into mechanical energy. From the turbine, the mechanical energy is converted into electrical energy. So many steps are involved in a thermal power plant. Because of the multiple steps involved, the efficiency is very low. Also, it causes considerable amount of environmental pollution. Fuel cell is a device which can directly convert fuels into electricity just in one step in a cleaner manner. Fuel cell can be considered as a galvanic cell in the sense that it can convert chemical energy into electrical energy. Here also, like batteries, we are generating electric power from chemical reactions. By fuels, we mean oxidizable chemicals. We are not feeding the fossil fuels directly here. We have to feed oxidizable chemicals like hydrogen gas, methanol, sodium borohydrate, etc. Okay. So here also we have two electrodes and an electrolyte, just in the case of a galvanic cell. The fuel and the oxidant. Fuel is supplied to the anode and oxidant is supplied to the cathode. As long as we supply the fuel and oxidant, the fuel cell keeps on giving power. What are the differences between a battery and a fuel cell? Both the devices convert chemical energy into electrical energy. This is a common point. Second point is, the lifetime of a battery is limited by the amount of chemicals present in it. As the chemicals get depleted, the battery will be drained. Whereas in a fuel cell, lifetime is not limited, because as long as we supply the fuel and the oxidant, it keeps on working. Okay. Next point is, in a battery, we use reactive electrodes like zinc, nickel, copper, etc. In the case of Daniel cell, we just saw that the zinc electrode dissolves. It undergoes oxidation. The zinc electrode becomes thinner and thinner. Whereas in fuel cell, inert electrodes like platinum are used. In fuel cell, the inert electrodes do not take part in the reaction directly. They just act as platforms to accept and give electrons. They just act as electron conductors. They do not directly get involved in the reaction. So this ensures that the lifetime of the fuel cell is very high. Next point is, a secondary battery, rechargeable battery, can be used for storing electrical energy. That's what we do at house. The inverter battery system, when power is on, it gets charged. When power cut is there, it will give the electricity. So we are using lead acid batteries to store electrical energy. Whereas fuel cell cannot be used like that. As long as we supply the fuel and the oxidant, we get the electric power. If we stop supplying, it will stop. That's all. That is, it cannot be used as an energy storage device. So fuel cell is called an energy conversion device. Battery is an energy storage device. Next point is, for a battery, voltage is the important parameter. Whereas for a fuel cell, power is the important parameter. Power is more important than voltage. For a battery, catalyst is not needed. But for a fuel cell, we use catalyst. The catalyst is coated on the electrode surface. Why we need a catalyst? In the power output, power is current multiplied by voltage. The current value depends on the rate of the reaction. The reaction should be fast for a fuel cell. So to speed up the reactions, we need a catalyst. Okay. Now we will go to a very common fuel cell, hydrogen oxygen fuel cell. Here at the anode, hydrogen is oxidized. Hydrogen gas is passed to the anode. It is oxidized to give H plus ions and electrons. At the cathode, oxygen gas is passed, which is reduced to give water. The overall reaction is the combination of hydrogen and oxygen gases to give water. A single cell gives a voltage of 1.2 volts. Here also, to add up the voltage, we can make a stack of the individual fuel cells. Now, I will show you one animation. This is a hydrogen oxygen fuel cell. Here we have two electrodes, the anode and the cathode. And in between, you have the electrolyte. It's a polymer film which can conduct ions. It's a solid electrolyte which is sandwiched between the anode and the cathode. Now we pass hydrogen gas to the anode, oxygen gas to the cathode. At the anode, H2 will be oxidized to 2H plus and 2 electrons. The electrons will travel through the external circuit and give electricity. They will reach the cathode, whereas the H plus ions will move through the electrolyte and reach the cathode. At the cathode, what happens? The oxygen gas takes up, oxygen molecules take up the electrons coming from the anode and get reduced to OH minus ions. The OH minus ions coming from the reduction of O2 will combine with the H plus ions coming this way. H plus ions and OH minus ions will combine to give water and we get electricity. This is how a hydrogen oxygen fuel cell works. As long as we supply the gases, we are going to get the electricity. So these are the reactions in a hydrogen oxygen fuel cell. Anode, hydrogen is oxidized to H plus ions, whereas at the cathode, oxygen is reduced. We get a cell voltage of 1.2 volts. So today we have covered batteries and fuel cells in a simple way. I hope you enjoyed the class. You can find more of our notes with solved problems and test series for NEET preparation as well as for NCERT at the Amazon Kindle store. If you just enter the author name, Dr. Meera Parthasarathy, you can see the books. I have also given the links in the description box for easy access. If you would like to attend one-on-one online chemistry classes for NEET preparation or class 12, please feel free to drop an email to ennapanacademy@gmail.com. We wish you the very best in all your endeavors.